Hello there guys, in this video I'm going to explain to you about chemistry paper 4 extended specimen paper for examination from 2023. Okay, this is the code of the chemistry paper 0620 and the time duration here is 1 hour and 15 minutes. Okay, so let us move on with the first question. Okay, for the first question, element X can undergo the following physical changes. Okay, as you can see here, this is a gaseous X, liquid X, and solid X. Okay, so here's the process 1, 2, 3, 4. Okay, the first one, 1A1, name each of the numbered physical changes shown in figure 1.1. So the process here, solid to liquid, will be melting. Okay, the second one, gas to liquid, will be under condensation. Condensing or condensation. Okay, number 3 here, the liquid to solid, so here will be freezing. Okay, now for number 4, liquid to gas, here will be, you can write either boiling or evaporation. Okay, now let us move to the next question. Let me scroll down here. Okay, now they're asking us to one difference between boiling and evaporation is the rate at which the process occurs. The rate, it means the boiling is much more faster compared to evaporation. Okay, so this is the meaning of this, the rate at which the process occurs. State one are the differences between boiling and also evaporation. So what you can say here is, okay, you could say boiling occur at a specific temperature, like water, it will boil at 100 degrees. Like alcohol, like ethanol, it will boil at 78 degrees. Okay, so while evaporation happens over at any temperature, so as long as they can absorb the heat, and evaporation happens. Okay, now we will go to the question B. Okay, question B here states, describe the separation, arrangement, motion of particles of element X in a solid state. Okay, so the solid state, it appears to be touching each another. Okay, so their separation here will be, you can also mention touching. Okay, their arrangement is very regular. Okay, the arrangement is very regular and they will be keep on vibrating. So your motion, you can write as vibration, vibrating. Okay, now the last one, C. Element X is a group 3 metal, it means it's group 13. It burns in air to form an oxide. Okay, they are asking us to write an symbol equation for this reaction. Okay, so we will have here X plus with, it burns in air, so we will have oxygen, so it's O2 here, and then will be getting the product, which is X2 and oxygen 3. Now we have to balance this equation. Okay, X is 2, so we can write here 2 first. Okay, since we have here O is 3, so we can make it balance. We make, okay, now we make the oxygen to be even number, so I put here 2 and I put here 3. So now we have oxygen about 6 atoms and the oxygen here is 6. So we have balanced the oxygen Now we have to balance the x. So the x here is 4, so we can write here 4. Okay, so we have balanced this equation, so we are getting here 2 marks, and the total for the first question is 10 marks. Okay, question number 2. Magnesium, calcium and strontium are group 2 elements. Complete table 2.1 to show the electronic configuration of a calcium atom. Okay, now calcium atom, we can refer to our periodic table. So the calcium, as you can see here, we have about 20. Okay, the electron number here is 20. Okay, now we go back to the question. So it has a proton number and electron number which is 20. Okay, now they're asking for electronic configuration, and this is a shell 1, 2, 3, 4, and a number of electrons. So this 20 can be separated into first shell maximum is 2, second maximum is 8, the third one is 8, and the last one here will be 2, and the combination here will be 20. Okay, so this is the electronic configuration of a calcium atom. This is 1 mark. Okay, now let us move on with the next one. Okay, B. Describe how the electronic configuration of a strontium atom is. Okay, now let us look at the strontium atom. Okay, as you can see just now, we have a calcium over here, and we have a strontium below calcium. So we have a 1 period extra over here, okay, for strontium. So the electron number for strontium is 38 and calcium is 20. Okay, now let us go back to the question. Okay, now the electronic configuration for strontium we have is 38. Okay, and then they have here about 5 periods. So I just make that 1, 2, 3, 4 and 5. Okay, the last one we will know which is 2. Okay, so here will be 2 and 8. So what happens here is 38, we minus with 12, and we will be getting 26. Okay, so we can place a maximum number at our third period, which is 18, and here will be 8. So this is the electronic configuration for strontium atom. So, and they are asking the first question, how the electronic configuration of strontium atom is similar to electronic configuration of a calcium atom. So we can explain in a way where the valence electron of a strontium atom and calcium atom is the same. Okay, and then we go to the next question. Okay, how the electronic configuration of a strontium atom is different from electronic configuration of a calcium atom. So calcium atom, it has a lesser 1 period compared to strontium, or you can answer in either way around. Strontium atom has more 1 shell, okay, compared to calcium. So this is how I write the answer. Okay, strontium has an outer electron in the 5th shell. Or you can explain strontium has a extra 1 period compared to calcium atom. Okay, so here's 1 mark and here's 1 mark. Okay, now let us move to the next question here. Okay, for 2C, calcium react with cold water, okay, to form 2 products. One is a colorless gas P, which pops. Okay, if you see the pops, this is confirmed it is a hydrogen gas, and a weakly alkaline solution which turns milky when carbon dioxide is bubbled through it. So here should be, okay, so this one should be a calcium hydroxide. Okay, now name the gas P. Okay, we know the answer is a hydrogen gas. Okay, identify the ion responsible for making the solution Q alkaline. So it should be the hydroxide. Okay, the hydroxide ion here. So you just can write down the answer. These are the ion, or you can put the full name, hydroxide ion. Okay, suggest the pH of a solution Q. Since they have mentioned it's a weakly alkaline solution, you can mention in the range of 7 above, 7 to 11. Okay, so 7 to 11. So you can suggest a pH. So maybe I just can put here like a 8.2 pH. Okay, so this is your 1 mark, 1 mark, and 1 mark. Okay, the next one, write a symbol equation for the reaction of calcium with the cold water. So calcium plus with cold water, and you'll be obtaining calcium hydroxide, and you will produce hydrogen. Okay, remember group 1 and group 2, when they react with cold water, they will be giving out the similar equation. So you will produce a hydrogen there, and hydrogen, and also metal hydroxide. Okay, so here is a 2 marks for this question. Okay. Okay, 2D, magnesium react with chlorine to form magnesium chloride. So this is the formula. Okay, magnesium chloride is an ionic compound. Complete the dot and cross diagram in figure 2.1 of ions in magnesium chloride. Shows the charges on the ions. Okay, now let us scroll this. So here we'll be having magnesium and chloride. Okay, so we have to understand first, magnesium, initially it has about 12 electrons. So your configuration here will be 2.8.2. Okay, then when they change to ion, what happens is the magnesium will donate the 2 electrons. We will donate out the 2 electrons, and here we have 2 positive. So now your electron configuration here is 2.8. Alright, so we can place here 2 positive, and we have to put here one more shell. Okay, one more shell. So let me draw it properly. Okay, looks better. Okay, now we have to put here, since they are using a cross over here, so we have to put a cross, 8 cross, so we can put a pair like this. So we now got 4, now we have 6, now we have 8. Okay, so now we have to understand about chlorine. So chlorine, basically they will have about 17 electrons, and your early configuration here is 2.8.7. so they will be receiving 1 electron. Okay, receiving 1 electron, that's what makes them -1, and your new configuration here will be 2.8.8. so remember, 1 is borrowed from, donated from magnesium. So we have to draw one more shell here for both chlorine and not to forget, we put here -1. We just can put minus. Okay, since they mention 7 is from the chlorine, right? So we just put that 7. 1, 2, 3, 4, 5, 6, 7, and the last one should be cross. Okay, is donated. Okay, same thing we are going to do over here. So 1, 2, 3, 4, 5, 6, 7, and the last one will be donated to here. Okay, so this is your complete answer. This is for 3 marks. Okay, so I hope you can understand this. Okay, now let us move on with the next question. Okay, for number 3, what physical property typical of ionic compounds such as magnesium chloride is that they are soluble in water? Okay, so this is one of their properties. So give 2 other physical properties. So for ionic, we can also mention it has a high boiling point. Okay, they have a high melting point and also boiling point. And you also can mention, since they are ionic compound, they are a very good electrical conductor when it is a molten. So very good electrical conductor. You can say good electrical conductivity when you can also mention in molten or aqueous. Okay, aqueous solution. Okay, the last one, aqueous silver nitrate. Silver nitrate, just write down the formula. Okay, so Ag is positive and nitrate ion is negative 1, is added to aqueous magnesium chloride. Okay, this is your magnesium chloride. Okay, a white precipitate form. So when they are combined, so I just write down this equation here. Mg chloride. Okay, so what happened here is the Ag, the argentum silver, will be combining with the chloride. However, the magnesium will be combined with nitrate. So put a bracket here. Okay, nitrate salt is soluble. They are soluble. Okay, so they do not form the precipitate. So however, your argentum chloride will form the precipitate. So we can write an ionic equation for this reaction. So which is Ag, this is aqueous, and your chloride is also aqueous, and you will form argentum chloride, which is a solid. Okay, this is 2 marks. So total for the second question here, the marks is 15 marks. Okay, now let us move to the third question. Okay, number 3, copper is a transition element. It has variable oxidation state. Okay, and then the A state 2 other chemical properties of transition element which makes them different from group 1 elements. Okay, you can say chemical properties. So you cannot mention about a high density or heavier. Okay, so they're asking for chemical properties. So you can say it acts as a catalyst. Okay, the another one, number 2, it will form a colored compound. Okay, like copper will form a blue color solution. So listen here, you can mention it forms colored compound, or you can say colored solution. Okay, now let us move to the next question. Okay, here, when copper 2 oxide, which is, okay, they already given equation here, so I don't have to write the equation. So it's heated with 800 degrees. It undergoes a reaction shown by the equation. Okay, so here they have been, here's copper 1. Okay, this is copper 1, this is copper 2. So, and here's oxygen is being released. Okay, number 1, identify the changes in oxidation number of copper and oxygen in this reaction. So if you notice that the first one, okay, the first one, CuO, so here will be 2 minus, here will be 2 plus. So here will be 2 plus, and then over here at this part, Cu2O. So here, the copper here is actually, they have one positive one as the oxidation number, and your oxygen here is a 2 negative. So that's how they form 2. So what you can realize from here, the copper's oxidation number is changing from 2 positive to a positive 1. So we are changing positive 2 to positive 1. Okay, now the second one, change in oxidation number of oxygen. Okay, the oxygen here, you can write, first is negative 2, so which will be taking from here. Okay, the first one, negative 2 to, so here is a molecule of oxygen, so here will be 0. All atom and molecules, they will have a 0 oxidation number, so here we have 0. Okay, and then your explanation. Okay, so the explanation here, you have to refer to this. Explain in terms of change in oxidation number why this is a redox reaction. Redox reaction means we will have a oxidation and also reduction process in the same equation. You can write here, increase in oxidation number. Oxidation number is oxidation. Okay, so the oxygen is undergoing oxidation. Okay, however, and you can add on here, let me change the color. Okay, you can also mention decrease in oxidation number is reduction. Okay, so the reduction case will be going for copper. So this is a reduction, and your oxygen here, it undergoes oxidation. Okay, so here is 3 marks over here. Okay, now we move on with the next question here. Okay, they mention calculate the volume of oxygen measured at RTP. RTP, just remember, is a 24 dimetric cube, which is formed when 1.6 gram of copper oxide, okay, this is 1.6 gram, reacts as shown in the equation. Okay, so now, okay, so you can refer to your periodic table, your RAM. Okay, your relative atomic mass for copper here will be 64, and your oxygen here will be 16. So mass, we have to find the mole first. Okay, the mole. So the mole for here will be divided by is RAM, so which is 64, we plus with 16, so we are getting here 1.6 divided by 80, so which will giving us 0.02 mole. Okay, so they are asking us to calculate the volume of this oxygen. So now we have to use this ratio. So here you can see the number 4, 2 and 1, which is 4, 2 and 1. So 4 is equivalent to 0.02 mole. So how about 1? because we are going to use is oxygen. So here will be divided by 4. It's just like a simple ratio. Okay, so here will be divided by 4, so which will be giving you 0.02 divided by 4, and the mole here is 0.005. Okay, so this is the mole for oxygen, 0.005 mole. So after we obtain the mole here, so what we can do, we can multiply this mole with 24 dimetric cube, which stands for RTP. So here will be 0.005 multiplied with 24. So you'll be getting here 0.12 dimetric cube. Okay, so this is the calculation. So you'll be getting here about 3 marks. Okay, now let us move to the next question here. Okay, for C, copper metal is obtained when scrap iron is added to aqueous copper 2 sulfate. Okay, copper 2 sulfate. So we can do an equation here, ferrum added to copper sulfate. Okay, and then because ferrum is much more reactive compared to copper, so the ferrum will displace the copper and become so this is 3. So we will have a ferrum iron sulfate plus with copper. Okay, so we are obtaining copper. So this displacement process, the reaction between iron and aqueous copper to sulfate is a displacement reaction, as I mentioned before. Okay, this is the example. Okay, state why this displacement reaction takes place. Because you can mention ferrum is more active or reactive compared to copper. Okay, this is your 1 mark question. Okay, now so number 2, write a symbol equation for the reaction between iron and aqueous copper 2 sulfate. So we can copy down this equation. Or because here I'm using, okay, this is a mistake here, so I put here 3. Okay, so for this equation I'm using a iron 3 positive. So let's say if you are using a iron 2 positive, so it will be much more easier. So copper sulfate, and they will just replace, because sulfate is 2 negative here. Okay, so you just will replace this and you will produce copper. So you can use either this equation or this equation. Okay, so this one I'm using a copper 3, and the oxidation number is a 3 plus, and here is the oxidation number for this iron is a 2 plus. Okay, alright, so now number 3 here. A displacement reaction is one method of obtaining copper metal from aqueous copper 2 sulfate. Identify another method for obtaining copper metal from aqueous copper 2 sulfate. So you can think about electrolysis. Okay, electrolysis process. So you'll be getting here 1 mark, 1 mark, and 1 mark. So total for this question is about 11 marks. Okay, now let us move to the question number 4. Okay, number 4, sulfuric acid has many uses. Sulfuric acid is a strong acid. Define the term acid. Okay, acid is a proton donor. So just remember this this answer. Okay, proton donor. However, if they ask us about define the term of base, the base here will be a proton acceptor. Okay, this is a proton acceptor. So this question, Okay, this question they have been repeating since 2018. Okay, and it's repeated again in 2019 and 2022. Okay, so define the term strong acid. Okay, strong acid, they will completely dissociate. So here is the, okay, define the term strong acid. Strong acid will completely dissociate. If you're talking about weak acid, then weak acid here will be partially dissociates in the solution. Okay, so please go through your revision. This is 1 mark here, this is 1 mark. Okay, next we are going to this B. Okay. Okay, B. Dilute sulfuric acid is used to make salt known as sulfates. A method consisting of 3 steps is used to make a zinc sulfate from zinc carbonate. Okay, so we can write down here the equation here. Now we will have a zinc carbonate. Okay, zinc carbonate, and then you combine with sulfuric acid, and you'll be getting here zinc sulfate, and you will produce carbon dioxide plus with water. Carbon dioxide due to this carbonate. Okay, so okay, step 1, add an excess of zinc carbonate. So it's a 20 centimeter cube of 0.4 concentration. Dilute sulfuric acid until the reaction is complete. Okay, now step 2 is filter the mixture. Step 3 is heat the filtrate until a saturated solution form and then allow it to crystallize. Okay, number 1, suggest 2 observations which shows that the reaction is complete in step 1. So since we have a gas over here, so we can also say no bubbles form. Okay, or you can also mention as a no more fizzing. No more fizzing. Okay, now the step number 2 here, what you can say white solid, or you can say white precipitate remains. Okay, so these are the 2 observations. Okay, number 2, state why is this important to add an excess zinc carbonate in step 1. So the main purpose here is to use up all these acids. Okay, so I can write down here to use up all the acids. Or you can say it's a hydrogen ion. Okay, now we go to the next question. Okay, the next one will be define the term saturated solution. So here I'll be giving you the answer. Okay, so you can answer a solution that can hold no more solute. Okay, they are not soluble more at a specific temperature. Okay, the next one here. Name another zinc compound that can be used to make zinc sulfate from dilute sulfuric acid using this method. Okay, so we can suggest zinc oxide, okay, or zinc hydroxide. So we can write down here the formula, zinc oxide or zinc hydroxide. So here will be ZnOH, and here put a bracket and 2. Okay, suggest why this method would not work to make barium sulfate from barium carbonate and dilute sulfuric acid, because barium sulfate is insoluble. Okay, barium sulfate is insoluble. You can say because barium sulfate is insoluble. Okay, so this is 1 mark here. Okay, we move on with next question. Okay, in a titration, a student added 25 centimeter cube of a 0.2 molarity aqueous sodium hydroxide to a conical flask. The student then added a few drops of methyl orange into the solution. Okay, then dilute sulfuric acid is then added from a burette to the conical flask. The volume of dilute sulfuric acid needed to neutralize the aqueous sodium hydroxide was 20 centimeter cube. Okay, the reaction is shown by this equation. Okay, now the first question here, state the color of methyl orange in aqueous sodium hydroxide. Okay, this is alkaline, so the color of methyl orange here will become yellow. Okay, now determine the concentration of dilute sulfuric acid in gram dimetric cube using the following steps. Okay, so let me scroll down a bit here. Okay, the first one is to calculate the number of moles of aqueous sodium hydroxide added to the conical flask. Okay, so we can use this formula mv divided by 1000. So which means is m stands for molarity and multiply with the volume in dimetric cube. So here we are getting the molarity 0.2. This is equals to mole. Okay, so we can use this formula. So the m stands for the molarity 0.2, and then we multiply the v is the volume in centimeter cube. Okay, so it will be 25. Then you divide it with 1000. Divided with 1000 to make it dimetric cube. So we find this is the answer for this. Okay, so the answer I got here is a 0.005 mole. Alright, so now let us move on with the next question. Okay, they are asking us to calculate the number of mole of a dilute sulfuric acid added from the burette. Okay, I have copied this equation again. Okay, just to show you. Okay, the number of moles of sodium hydroxide here is 0.05, and then you have to be look at this ratio here. So this one, the number is 2, here's 1, right? So the mole, so the ratio can be only divided with this mole. So the 2 is 0.005. If you have 1 here, just divide it by 2. Okay, so here you'll be getting there 0.0025. 0.0025. This is the mole for dilute sulfuric acid. Okay, now let me scroll down. Okay, now they're asking to calculate the concentration of dilute sulfuric acid. Okay, to concentration of dilute sulfuric acid. To calculate the concentration here, okay, to calculate the concentration here, we need mole and also the volume. So the mole here we obtain is 0.0025, and the volume here you can find from the question. So let me scroll up here. As you can see, the volume is given. Okay, look at here. Okay, the volume of a dilute sulfuric acid needed to neutralize the aqueous sodium hydroxide is 20. Okay, it's a 20 centimeter cube. So now we are going to use this in this calculation. So here will be, so it is 20 centimeter cube. So we have to divide with 1000 in order to obtain the value in the metric cube. So here will be 0.02. Okay, 0.02. So the volume here is given by 0.02. So let us find this answer. So we'll be getting the answer 0.125. That is the molarity of a sulfuric acid. Okay, now let us go to the last question. Okay, here they're asking us to calculate the concentration of dilute as sulfuric acid in a gram. So from mole to mass, we have to multiply with its RMM. Okay, so let me scroll further down. Alright, so we have more space. So for RMM, the RMM for sulfuric acid here, your H is 1, S is 32, oxygen is 16. So your total calculation for your RMM here will be, H you have 2, so it's 2 plus with sulfur is 32, and your oxygen here will be 4 multiplied with 16, and total you will be getting here 2, 32, and here 64, and here will be about 34. So all total you will be getting here 98. Okay, so we just have to take this answer 0.125 multiply with 98. So we see how much we get there. So you'll be getting about 12.25, okay, gram per metric cube, and this is the total 4 marks for this question. And the question 4 here, we have a total about 14 marks. Okay, so I hope it helps your revision, this one. Okay, now let us go to the next question here. Okay, question number 5. A student investigates the process of reaction between dilute hydrochloric acid and an excess large piece of marble calcium carbonate using the apparatus shown in the figure 5.1. Okay, so here we have an acid, okay, hydrochloric acid, and here we have a large piece of marble, so calcium carbonate. Okay, now, okay, so let me scroll down. So here we have a graph of volume of gas produced against time is shown in the figure 5.2. So the equation here, we can write it hydrochloric acid plus with a calcium carbonate, and you'll be releasing, you will have here calcium chloride, and we will have carbon dioxide plus with water. Okay, so these are the gas that they mentioned, carbon dioxide. So okay, so they goes up and they have settled over here at this point. Okay, let me scroll down again. Okay, now the question says, they're asking us, state how the shape of the graph shows that the rate of reaction decreases as the reaction progresses. Okay, now let us answer the first question. Okay, the shape of the graph. So you can write the gradient of the graph decreases. Okay, that is showing the rate of the reaction decreases. So you can say gradient decreases. Gradient of the graph decreases. Okay, so this is a 1 mark here. Now we look at the second question. Suggest why the rate of reaction decreases as the reaction progresses. So you can say either the concentration of the acid reduces, or you can also say the number of reactant molecule decreases. Okay, concentration of hydrochloric acid decreases by time. Okay, so that's your 1 mark here. Then the last question, okay, deduce the time at which the reaction finishes. Okay, the reaction finishes. So we look back at our graph. It ends exactly over here at this part. Okay, as you can see, the gradient is slowly going, slowing down, and here we have a completely zero gradient. So it stops exactly at this part, so which is about 200 seconds. Okay, so that is your answer. So we can write here 200 seconds. Okay, now this is the question for B. The experiment is repeated using the same mass of a smaller piece of marbles. So all other conditions are kept at same. Okay, draw a line on the grid in 5.2 to show the progress of reaction using the smaller piece of marble. So here the rate will be higher. Okay, the rate of reaction here will be higher. So let me draw this. Okay, so now I'm going to draw the graph now. So this is for the large piece of marbles. So now I'm going to draw for the smaller piece. So smaller piece will have a faster rate of reaction. Okay, so they'll have a faster, and then they will be leveling down. Okay, they'll be equal to this line before 200 seconds. Okay, so as you can see, this is a smaller piece. This is the larger piece. So the smaller piece will have a higher rate of reaction. Okay. Okay, so this is a 2 marks. Okay, now C. The original experiment is repeated at a higher temperature. All other conditions are kept the same. The resulting increase in rate of reaction can be explained in terms of activation energy and collision between the particles. Okay, define the term activation energy. So let me write down here the answer. So your suitable answer here will be minimum amount of energy to collide and react with the particles. So you will have efficient collision that produces the results. Okay, now we are going to the last question for question number 5. So here, explain why the rate of reaction increases when temperature increases in terms of activation energy and collision between the particles. Okay, so these are the keywords that you should follow for this type of question. And remember, the same question has been asked since 2018. Okay, so when the temperature increases, you will have a higher movement, so which is the higher kinetic energy. And you will have, when you have high kinetic energy, so obviously you will have more frequent collision between the particles, and there will be a higher percentage or higher probability of particles with higher activation energy to form the product. So remember, for your 3 marks you have to include all these keywords. Okay, so for this question the total is 10 marks. Okay, now let us move to the question number 6. Okay, for question number 6, Alkynes and Alkynes are homologous series of unsaturated hydrocarbons. So Alkynes contains a triple bonding, okay, of a carbon. So complete table 6.1 showing information about these first 3 alkynes. Okay, so this is a formula, this is structure, and these are the names. So here we have okay, now look at the names here. So here we have a Y and E, Y and E. So carbon 2 is pentane, eth. So carbon 3 we will have a prop. Okay, just remember the name prop, and then you continue with a Y and E. Okay, here they are asking the combination. So C we have 1, 2, 3 and 4. So C is 4, and the H here will be 2, 3 and 6. So it's C4 and H6. So this is the 2 marks. Okay, now let us move to the next question. Okay, compound in the same homologous series have the same general formula. Give 2 other characteristics of members of homologous series. So here they'll be having a same functioning group. And then the second one here will be, they'll have a similar chemical properties. Okay, now deduce the general formula for alkenes. Use the information from table 6.1 to help you. Okay, so let us scroll up. Okay, and to deduce the formula. Okay, now we have C2H2. Okay, so we have to look at these formulas. Okay, so the best formula here is Cn, and if you notice, the H will be double up for every carbon increasing. Okay, so here you need to get 2n. Okay, so here's 2n. So if you put here 2n, it will be doubling up. So, and we have to put here minus 2. Okay, so this is 1 mark here. So let us scroll further down. Okay, now alkynes are unsaturated. Okay, describe a test for unsaturation. So at unsaturation here, the best is you can test with a bromine water. Okay, we can test with a bromine water or bromine solution. Okay, so bromine water and bromine solution here, they will be is in a brown color. Okay, brown to red color. So bromine, okay, remember this one guys, when you have the Br2 here, it is in brown color. Once they have split into ions, or they have a single Br, this one it will be colorless. Okay, so you'll be having the results changes to colorless, or you can say brown to colorless. So I just put here changes to colorless. Okay, so which is referring to this one. Okay, this is 2 marks here. Okay, and then the last question here, not the last for this page. Okay, now ethene and but-2-ene are alkanes. So draw and displace formula of 2-but-2-ene. Okay, so but we have here about 4. Carbons. Okay, 4 carbons. So we just write here 1, 2, 3 and 4, and the location for the double bonding. Okay, alkane, you must have a double bonding here between the carbon. You must have 1. So this is the location. This 2 here is the location of the double bonding. So we can choose carbon 1, carbon 2. Okay, location of double bonding at the second carbon. The rest of it you can, okay, remember carbon you must have 4 bondings. Alright, 4 bondings here. So for the rest we can add on with the hydrogen. Okay, so here we have 1, 2 and 3. So we can add in another one more here, and all this is hydrogen. So this is a 2 marks question. Okay, draw a dot and cross diagram to show a molecule of ethene. Okay, dot and cross diagram. So carbon, we have about 6 electrons. So here will be 2.4, and hydrogen is only 1. Okay, so your connection here will be C double bond, and here we have hydrogens. Okay, here we have hydrogen. So carbon we draw 2. So here's 1 more, and 1 more a bit bigger. So let me make it a bit closer. Okay, so I'll draw the second one. Okay, then another one here. Okay, so let me solve for, okay, let's say I put a cross for carbon. Okay, so we have here 2 at the first shell and the 4. So here you'll be having 2 bondings. So 1 and 2. Okay, let us draw the hydrogen now. So hydrogen you have only 1 here and here. So hydrogen 1 and 2. Okay, and then I can complete the cross. I put here 1, here 1, here 1 and here 1. Okay, now I'm going to put a dot for hydrogen. Okay, now it looks okay, but let me adjust this. So okay, I adjust this part. Okay, so for hydrogen there is not an issue. So here, okay, let's say for this carbon I select the green color. Okay, so I have 1 and 2, and then for this carbon I select the cross. So here I'm putting a cross here, and 1 and 2. So for carbon we have total 1, 2, 3, 4, 5, 6, 7, 8 for this carbon, and 8 electrons for this carbon, and you manage to form the bonding. So this is the single bonding. Okay, this bonding is referring to here. This one is this part. Okay, if you look at these two bondings is from here, and then the main one is this double bonding, which is here, the double bonding. Okay, so this is your answer. Okay, so this is your complete answer for 2 marks. Okay, now let us move to the next question. Okay, now here ethane can be converted into ethanoic acid by two-stage process. In stage 1, ethane is converted to ethanol by catalytic addition. Right? Okay, suggest why stage 1 is called an addition reaction. Okay, why is it called as an addition reaction? It is because water molecule, okay, because water molecule is added into ethane to form one product. So which is your ethanol. So we can put a bracket here. Okay, so this is your answer here. So this is 1 mark. Okay, the second one, a catalyst is used in stage 1. So the catalyst here will be steam. Okay, steam is used. Steam means it's 100 degrees of gas. Okay, steam is 100 degrees of gas. You don't have to write it. Steam is being used, and the pressure ATM here will be about 20 to 80 ATM. Okay, it is the pressure. Okay, now state what must be reached. State what must be reacted with the ethanol to form ethanoic acid. So here we need to have acidified potassium manganate. Okay, acidified potassium manganate. So you have to add on here the word acidified. Acidified potassium manganate. Okay, this is your 2 marks question, and here the total marks is 15 marks for this. Okay, for question 7, carboxylic acid can be converted into ester. Okay, propanoic acid and methanol. Propanoic acid and methanol react to form an ester that has a molecular formula of this: C4H8 and O2. Name this ester and draw its displayed formula. Okay, now the propanoic acid, it has a formula of CnCOOH. Okay, so this is your general formula of this carboxylic acid, and alcohol, you have a formula of this 2 + 1 OH. And remember, for carboxylic acid, when you are adding the N over here, you have to minus with 1. Now for example, we have a propanoic acid, carbon is 3, right? So we have to minus 1 and substitute here. So here we will have C. So we will have that 2C. Okay, so the C is 2 and H is 5, COOH. So here you have C, double bond, and you have OH. The rest is hydrogen. Okay, and then you'll be combining with methanol. So methanol is C1. So OH. Okay, let me put it further side. So okay, So you got there C1 and H3 and OH. Okay, so OH. Okay, now when they are combining, okay, so let me complete here. So here, just remember here we have a H. Okay, now when they are combining, this one, the OH at the alcohol and a H from the carboxylic acid will combine to form water. So you'll be getting the entire product as C and here's O, and you will combine with alcohol C H H H, and I write it here. Here we have H. So here we have total about 5H. Okay, and then you will plus with water. Water is from here. These two will form the water, and this is the structure. This is the structure, the complete structure for this ester. Okay, so here's the H. Okay, so this is the displayed formula, but I have shown you the entire process. So the naming, okay, the naming here you have to take from alcohol first. So this one will be as methyl, and this one will be as methyl. The first name must be from alcohol. Okay, must be from alcohol, and then the second one you have to take it from your acid. So this is propanoic acid, so we have to put here propanoate. Okay, so here will be name another ester with the same molecular formula. So here you can see there's a carbon is 4, right? So we can make it like ethyl. Okay, ethyl also has a carbon 2, and they are combined with ethanoic acid, so they'll form an ethanoate. Okay, so we will have the same formula over here. So this is 1 mark question, and then we move to the next one, so which is the last question for this paper. Okay, polyester are polymers made from dicarboxylic acids. Name other type of organic compound used in formation of polyester. Okay, so to answer this question, let me explain to you what is a dicarboxylic acid. Okay, let me scroll down a bit to show you. Okay, now we have heard about carboxylic acid, right? So for carboxylic acid, we have a general formula where it is we have one carbon with double bond and with OH. So when you heard about dicarboxylic, di means is 2. So here you'll be having R, C, double O. Okay, so here you have a double O, OH. Okay, now, okay, this is a carboxylic acid, alright. So let me erase this, and I add on with another carbon here. Okay, let me put in different color. So this is a carbon, and we have another double bonding with oxygen, and then we have here O and H. Okay, this list can be continued. Okay, they'll continue to 3 to 4. So we have it can also be like this. So let me draw for you one more example here. So we can have like few carbons. Okay, and then we have here double bond with O, and we can have even here, okay, O, OH, and the rest is H. So this is all in the group of a dicarboxylic acid. So how do we get this dicarboxylic? So now we answer the question. Okay, so now you can see here this part. Name the other type of organic compound used in the formation of polyester. So should be diol. Alright. Okay, so I hope you can understand this. Okay, name the type of polymerization used in manufacture of polyester. So type of polymerization, here we have addition type. Okay, we have addition type and we have a condensation type. So this polyester will be in the form of a condensation. So this is your answer, and we have a total about 5 marks here for this question. Okay guys, so I hope this video helps you to revise. Okay, so all the best for your future IGCSE exam. Thank you very much. Please like and please subscribe the channel. Thank you guys.